Hi there, it's Professor Shannon Gracie back again. We're on section 3.1. We're using the Blitzer Introductory and Intermediate Algebra book. And here's our next topic. We'll be graphing linear equations in two variables. So what we were doing last time is we were solving linear equations in one variable, and so now we come into the two-dimensional plane. So we'll be doing all this great stuff, plotting ordered pairs in the rectangular coordinate system, finding coordinates of points in that same system, determining whether an ordered pair is a solution of an equation. A solution of an equation for a linear equation in two variables means that you'll have an x coordinate and a y coordinate, and you have to plug both of them in the appropriate areas and make sure you get an identity statement. We'll be finding solutions of equations in two variables using point plotting to graph linear equations, and we'll use graphs of linear equations to solve problems. So here we go. Why don't you go ahead and get warmed up. We've got two warm-ups there from our last material. Pause the movie and get going. All right, let's see how you guys did. Find the volume of a box with dimensions 1/2 foot by 3 feet by 8 feet. So the volume is equal to the length times the width times the height. So our volume will be 1/2 times 3 times 8, which will yield a result of, so here, just to kind of match it up, and there we go. So if you notice that from the, we can do this multiplication in any order. So I'm going to do the 1/2 times 8. That'll yield a result of 4. So our volume will end up being 12, and we have cubic feet. And we're good to go. How'd you do? Awesome. All right, so here we go. Now we're back to the inequalities again. We have to clean this one up a little bit. So we'll be distributing that 6 throughout the parentheses. So that gives us 6 times 3x minus 6 times 5. So here, these are equivalent. And then we'll have x is less than or equal to 18x's minus 30. Bring it up here. I'm going to go ahead and subtract 18x's from both sides. So this result will be here. We'll end up with negative 17x's less than or equal to negative 30. Now be careful if you did it in this manner. We're going to be multiplying both sides by negative 1/17 in order to get a coefficient of 1 in front of the x. So remember, in order to pay for that, we're going to have to flip the inequality. So we end up with x is greater than or equal to 30/17. So let's go ahead and do our graph. That means that x is to the right of or greater, to the right of meaning greater or equal to 30/17. So 30/17 is roughly what, 1 and 13/17. So that'll be a little over 1.5. So we'll go ahead and mark it about here. The square bracket is due to the or equal to part of it, and then we go infinitely to the right. So now that we've done our graph, let's do our interval notation. So that looks almost like the graph. We'll have 30/17, and we go all the way to infinity. And the set builder notation, our variable is x, such that x is greater than or equal to 30/17. Now remember that our author has stated that we're working in the real numbers, which is why we haven't put that in our set notation. All right, here we go. Actually, the answer is the whole thing, isn't it? The graph and the interval notation. So we'll just do a giant box around everything. Okay. Let's check out our next one. If we were to subtract 2 x's from both sides, we will get 0x minus 1 is less than or equal to 0x. Bringing it up here, that gives us 0 minus 1 is less than or equal to 0. Negative 1 is less than or equal to 0. So what do you think? Would you say, true or false? You got it. That bad boy is true. So what does that mean for our answer? Good. It means that it doesn't matter what number you plug in for x, you'll get a true statement. So we shade the whole entire number line for our graph of the solution, and the interval notation goes from minus infinity to infinity, and the set builder notation, x such that x is a real number. Good. All right. Well, hopefully you're all warmed up. So now we get into, some new material. Well, let's check it out. Good stuff here. Okay, points and ordered pairs. The idea of visualizing equations as geometric figures was developed by the French philosopher and mathematician René, and I think it's pronounced Descartes. This idea is the rectangular coordinate system, or the Cartesian coordinate system. So actually there's an A there. So if you make up your own math and it happens to be true, you get to name it after yourself. So here we go. The rectangular coordinate system consists of 2 number lines. So we've just been working with 1 number line. Now we have 2 number lines, and they intersect at right angles at their 0 points. The horizontal number line is the x-axis, and the vertical number line is the y-axis. The point of intersection is a point called the origin. Positive numbers are to the right and up the origin. Negative numbers are to the left and down the origin. the axes divide the plane into 4 regions called quadrants. This quad means 4, as you probably know if you go to the desert. The points located on the axes are not in any quadrant. Each point in the rectangular coordinate system corresponds to an ordered pair. Of real numbers, and they are often denoted by x, comma, y. The first number in each pair, called the x coordinate, denotes the distance and direction from the origin along the x-axis. The second number, called the y-coordinate, and then, oh, sorry, there's a little typo, denotes the vertical distance along a line parallel to the y-axis. Because if you moved, you know, for the first coordinate on the x, for the x-coordinate, if you moved right or left, you're not going to be right on the y-axis. So, but you'll be on some line parallel to the y-axis. Or it could be along the y-axis itself. It just depends on the movement of the x-coordinate. All right, so let's just check out a picture of all this going on here. So it's very important to always label your axes, right? So this one is the x-axis. That's right here, that horizontal line going right there. Over here, we have the y-axis. So, actually, you know, we can go ahead and let's highlight these things. So, the x-axis is this part. The y-axis is this line. Okay. Now the origin is right here. It's this ordered pair. The ordered pair 0, 0, which is called the origin. And then the quadrants, quadrant 1 starts here. So we have Q1 is quadrant 1. Now the ordered pairs in quadrant 1 are always going to be a positive x value because it's to the right and a positive y value. So you'll have a positive comma a positive. Now quadrant 2, it goes counterclockwise. So quadrant 2 is going to have what kind of sign on the x-coordinate? Good, negative. And a positive y. Quadrant 3, you're moving left and down, so good. We'll have a negative and a negative. And quadrant 4, we have rightward movement, so we're positive on the x-coordinate, but we go down from the origin, so we're negative. And that's the setup of the rectangular coordinate system. Okay, so let's check out how we would plot some of these ordered pairs. So 2 comma 5. The x coordinate is 2 and the y coordinate is 5. So that means we're going to go 2 units to the to the right and 5 units up. So we want to make sure we are labeling everything. So this is X and this is Y. I'm going to go ahead and have each of these tick marks be worth 1 unit. So this ends up being 10 and 10. Negative 10 and negative 10. These grids that I use have 10 tick marks up and down. Now, if you had wanted to have a different scale for one of the axes, that's fine as long as you do it for that whole number line that corresponds to that axis. Right? We'll just use the standard. So this will be each one of these is worth 1. So let's go ahead and graph this guy. We'll do this one in red, the first one in red. So we have to go 1, 2 to the right, and then 1, 2, 3, 4, 5 up. So that ends up being the ordered pair 2, 5. We good? All right, you guys try the next two. Pause it. All right, let's see how you did. For negative 3, 7, we're going 3 units to the left. And then 7 units up. So we'll do this guy in blue. So 1, 2, 3 left, 1, 2, 3, 4, 5, 6, 7 up. So we've got the ordered pair. Negative 3, 7. And finally, this is 2 units down and 4, I'll write it as a number, 4 units. Oh, I apologize. Remember, you're supposed to stop me when I make up my own math. That'd be 2 units left. Thank you. And 4 units down. And we'll do this one in green. So we have 2 left and 1, 2, 3, 4 down. I don't like where that ended up. Here we go. So this gives us negative 2, negative 4. All right. Next bit of information. A solution of an equation in 2 variables, x and y, is an ordered pair of real numbers with the following property. When the x coordinate is substituted for x and the y coordinate is substituted for y in the equation, we obtain a true statement. So let's check it out. And by the way, what do you think this means? If we get a true statement, what the heck does it mean? Good. It means that the ordered pair that you tested is actually a point that's on the line. Remember, a line's made up of infinitely many points, right? So if you if you plug in, like this first one, we plug in 0 for x and 1 for y. If we get a true statement, that means that the ordered pair 0, 1, that point, is on the line 8x plus y equals 1. So let's check it out. 8 times 0 plus 1. Is that equal to 1? So I plugged in my 0 for x and 1 for y. So I get 0 plus 1. Is that equal to 1? 1 equals 1. Check. So true. So what does that mean? That means that 0, 1 is a solution. Okay, why don't you guys try the next two and see what you find. Go ahead and pause the movie. Let's see how you did. When I plug in 8 times negative 1 plus 3, is that equal to 1? So again, we're using that same line, but now we're plugging in negative 1 for x and 3 for y. So we get negative 8 plus 3. Is that equal to 1? Negative 5. Is that equal to 1? Not unless you've been drinking, right? So here we go. We would say it's not equal to 1. This is a false statement. So that means that negative 1, 3 is not located on that line. It's still a perfectly fine point. It's just not on the line that is represented by 8x plus y equals 1. So negative 1, 3 is not a solution. And then let's see about 2, negative 15. So 8 times 2 plus negative 15, is that equal to 1? Again, this is our x-coordinate. Here's our y-coordinate. So 16 minus 15, is that equal to 1? 1 equals 1. That's true. So we would say that 2, negative 15 is also located on that line. So therefore it is a solution. Okay, now this is how we go about graphing lines. So the prior example was we wanted to figure out if those ordered pairs were on the line, if they were located on the line. Now, this kind of skill here is we can find ordered pairs and use those ordered pairs to graph the line. Now, you only really need 2 points to graph a line because the line is straight, it's not curved. But while we're starting out here with our skills, it's a good idea to start by using 3 ordered pairs. Or I apologize, start by using 5 ordered pairs and then go down to 3 ordered pairs, because if you make a triangle, obviously something went wrong somewhere. All right, but we'll be getting to that shortly. But first we're going to go ahead and find 3 points that are on this line. Now, you can pick whatever numbers you want. So what do you guys want to do first? Do you want to let x equal something or y equal something? Okay, so if we let x equal to 1, and I just picked a number, pick a number, any number. So I let x equal 1. All right, so this is for one of the ordered pairs, or I'm starting one solution. So let x equal 1. All right, so we would have 2 times y is equal to negative 1 minus 1. So I chose to let x equal 1. So now we need to find the y value that will correspond to that. So we'll get 2y equals negative 2. Now doesn't this look familiar? We learned how to solve linear equations in one variable in the last chapter. So you're using those skills in order to find the y-coordinate of this ordered pair. So here, if we multiply both sides by 1/2, we will get 1y is equal to negative 1. So what we have found is we found the ordered pair 1, negative 1 is a solution. The 1 came from what we chose to let x equal to, and the negative 1 is what we found for y. Okay, so here's another one. Why don't we let y equal something? So let's let y equal to, what do you think? 3. So then we would have 2 times 3 is equal to negative x minus 1. Right. This gives us 6 equals negative x minus 1. Yeah. Add 1 to both sides. We would get 7 is equal to negative x plus 0. So 7 is equal to negative x. We don't want negative x, we want positive x. So I'll multiply both sides by negative 1. And we'll get negative 7 is equal to positive x. So the ordered pair we found was negative 7, and we had let y equal to 3. So this is where we got the 3, and this is where we get the 7 from the negative 7 from solving for x. All right, so I'm not sure what you want to do for the next one. Why don't we let y equal to 0? So we'll get 2 times 0 is equal to negative x minus 1. 0 is equal to negative x minus 1. I'll go ahead and add x to both sides. And I'll get x is equal to, do you see we'll get 0 x's, which is 0, and then we'll get negative 1. So our solution for that guy is, oh, that was this one. So this one is going to be, getting ahead of myself. So we'll have the ordered pair negative 1, comma 0, because we had let y equal to 0. So this happens to be kind of a special ordered pair. Because this one, notice, is not in any of the quadrants. It's going to be on the x-axis. So this is actually also called the x-intercept. So we'll be learning about that in the next section. A lot of times people like to graph using intercepts. Okay, here we go. Graphing linear equations in the form of y equals m times x plus b. The graph of the equation is the set of all points whose coordinates satisfy the equation. So here's some steps. Just like we did in the prior example, we find, several ordered pairs that are, and remember, a line is straight. So if you've got one that's a little off kilter and the other ones all fall on the same, the same straight line, you should double check that one, your math on that one. So we'll be finding several ordered pairs that are solutions of the equation. Plot these ordered pairs as points in the rectangular coordinate system. Connect the points with a smooth curve or line. Now this is a general graph, so here an equation in two variables, you have to start recognizing certain forms. So if y is raised to the 1 power, so when y is raised to the 1 power, it'll just be y. And x is raised to the 1 power, so that would just be an x. If you have that situation, you're going to have a line, right? If you've got like x squared or some other kind of operation going on, then you'll get often some sort of a curve or some different shape. We're focusing on lines in this section. So here we go, y equals 2 times x. So in this case, do you see that it makes the most sense to plug in values for x and solve for y, since y is already isolated? So here we go. Let's go ahead and plug in several values. We could do 4. We would get y is equal to 2 times 4, which would give us y is equal to 8. So that would give us the ordered pair 4, 8. So we found a solution to that equation. So this is how we got our y coordinate. And this is how we got our x coordinate. And sometimes it's good to get several points before you start plotting the points so you know how to make your scale, right? So I'm gonna go ahead and find my ordered pairs, my points first, and then I'll go ahead and make the scale. So what number should I use next? All right, let's go ahead and use 3. So that would give us y is equal to 2 times 3. Oh, and this is where we had plugged in the x. So this will give us y equals 6. So we'll have 3, 6. Okay. And then 0 is always good to plug in. So we'd get y is equal to 2 times 0. So y will be 0. We get the ordered pair 0, 0. And then some negative values are also, good. So we could do maybe -2. So y is 2 times -2. That's what I'm plugging in for x. We'll get y equals -4. So we get the ordered pair -2, -4. And one more, maybe -5. So y equals 2 times -5. Y will be -10. So we'll get our ordered pair of -5, -10. right, so now let's make our picture. Y equals 2x is the name of the line. So you know how when you're thinking about your friends, and so if I say Rory, a picture of Rory comes into my mind, right? So if we say y equals 2x, we want to learn what the picture of that looks like. So first things first, we've got x and y as our coordinates, so we'll label the axes. Now it looks like if I do, negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis, I'll be good to go. I'm looking at my coordinates of my ordered pairs, and those will all fit with that scale. So here we go. Let's go ahead and graph our points. So 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6, 7, 8 up. That's 4, 8. And then 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. 0, 0. Negative 2, negative 4. 2 to the left. 1, 2, 3, 4 down. And then negative 5, negative 10. 1, 2, 3, 4, 5. And then it'll go down to here. All right, so if you see, they all seem to fall on the same line. So now it's good to take a straight edge to go ahead and do your line. I'll do the best I can on here. If I use a straight edge, it tends to I'm going off kilter a little bit there. There we go. And we'll put our arrows at the end to show it goes on forever, and we're good to go. Right? Now it's very, very important for you to know how to graph a line in the next section, or not section, the next chapter. We're going to be, graphing two lines on the same coordinate plane and trying to figure out a solution for that system of lines. So you really, really need to get your skills solid here so that you're successful at that next level. All right, I'd like you to try B and C all by your lonesome. See how you do. Now remember, for B and C, they're already set up where y is isolated, so it's going to make the most sense to plug in values for x and to solve for y. So we'll go ahead again. We're going to find 5 ordered pairs to make sure we've got this skill down and we're solving things right. And in the next section, we can move to 3 ordered pairs. Okay? So on your mark, get set, go. Pause the movie and do these problems. Okay, let's see how you did. We have y equals negative 3x plus 9. So let's see what we want to plug in here. We could do, I don't know, how about 2, 1, 0, negative 1, and negative 2. Remember, you can pick anything that you want to pick. These will just be easy to plug in. So here I'll get y is equal to negative 3 times 2 plus 9. So y will be, do you see I'll get negative 6 plus 9, so I'll get an end result of 3. If you need more room, get some scratch paper and work it out there. So I'll end up with the ordered pair 2, 3. Okay, And then y equals negative 3 times 1 plus 9. Y equals, let's see what we have. We have negative 3 times 1 is negative 3 plus 9 will give us positive 6. So we'll get 1 comma 6. Now when I plug in 0 for x, I'll get negative 3 times 0 is 0, so we'll just get y equals 9. So 0, 9. And then we'll get y is negative 3 times negative 1 plus 9. Y equals, let's see, that'll make it positive 3 plus 9 is 12. So we'll get negative 1, 12. And finally, y is negative 3 times negative 2 plus 9. So that means that y will be positive 6 plus 9, which is 15. So negative 2 comma 15 is the solution to that one. All right, so here we go. This is where we, plugged in. We just picked those numbers just because they're easy. These are where I plugged in all the x's. So here's our x coordinates, right? And then this is how we got the y values by solving that equation. And so then we got these results for y. Now, if this is why I was saying get your ordered pairs before you make your scale. For the x's, going from negative 10 to 10 will work just fine. But do you see the y's go all the way up to 15, right? So I'm thinking that maybe I ought to have the y's go by 2's. So if I did that, I'd have 2, 4, I'll do, that'd be 4, that'd be 8, that'd be 12, 16, and the top one would be 20. And then same for the bottom, 2, negative 4, negative 8, negative 12, negative 16, and negative 20. Okay, so here we go. So if so I'll go ahead and do my first one. So my first one, I'm going to go 1, 2, but be careful, 3 is going to be here in the middle. And then 1, 6, so 1 and then 6 is here. 0, 9, be here. Negative 1, 12. And then negative 2, 15. Be about here. Okay. And then we just make our picture of our line. So we can label them so that they're kind of close together, but and this was 1, 6, and this was 2 and 3. And then we just make the line that'll go through them. That I got off track. And there we go. How'd you do? So here we go. Let's see how you did. Now this one, you want to be kind of clever in how you choose your x values. If you do, multiples of 5, then it's going to be easier for you to make the picture of the line because the 5 in that 2/5 will divide out. So I'm going to go ahead and do that. I'm also going to put 0 in as well. So I'll go ahead and do, let's see, how about 10, 5, 0, -5, and -10 for my x values. Sorry. Uh-oh. Okay. So now we'll have y equals 2/5 times 10 plus 3. So the x value I chose was 10 because I want to get rid of that 5. So do you see 5 goes into itself once and into 10 twice? So I'm going to end up getting y equals 2 times 2 is 4 plus 3. So y is 7. So we will have 10, comma, 7. Then y equals 2/5 times 5. And again, if you want to do more steps, you do take out your scratch paper and do some more steps. So we'll get y is equal to, let's see what happened. 5 goes into itself once and into 5 once. So we get 2 times 1 is 2. 2 plus 3 is 5. So y will be 5. And if I plug in 0, I'll get 2/5 times 0 plus 3. So y will be 3. Plugging in -5 for x. We will have, you'll get a -1 there. So we'll get 2 times -1 is -2. -2 plus 3 is 1. Oh, sorry, I haven't been putting my ordered pairs. So this ordered pair ended up being 5, 5. This one was 0, 3. This guy was -5, +1. And now we're on our last. So y is 2/5 times, we'll plug in -10 for our x value, or x coordinate. So here, plug that in for x. And when you divide out of 5, you get -2. So you get 2 times -2 is -4, plus 3 will be -1. So y will be -1. Okay. So the ordered pair we get is -10, -1. All right, so these were all the x coordinates that we picked, right? And then we found y by solving for y. That's what our end results were. And if you notice, we can just go ahead and use our regular scale, each of the lines going from -10 to 10. Okay. All right, so I'm going to, well, we'll go ahead and still plot the points, or write in the order pairs. So 10 to the right, and then 1, 2, 3, 4, 5, 6, 7 up. So that will give us 10, 7. And then 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 up. 5, 5. And then 0, 1, 2, 3. And that's our y-intercept you'll be learning, because it intersects the y-axis. And then 5 to the left. And we had, whoops, 1, 2, 3, 4, 5. And 1 up. And then negative 10, negative 1 will be here. And so this line, nope, that's not a good start. And you guys really, really ought to be using a straight edge to graph the line. Again, that's a little shaky. I guess I had a little too much coffee today. All right, so that's our line. Now, would you guys consider this to be a positive or a negative slope? Good, it's a positive slope because as we move from right to left, the line goes up. We're going uphill. Did I say right to left? Let me make sure I said that correctly. As we move from left to right, we go uphill. As we move from left to right, we go uphill. So that's a positive slope. All right, so now comparing graphs of linear equations. If the value of m does not change, all right, so you have y isolated and m stays the same. The graph of y equals mx plus b is the graph of y equals mx shifted b units up when b is a positive number. Now, the graph of y equals mx plus b is the graph of y equals mx shifted b units down when b is a, oh, I apologize, we need to change this to negative number. So make sure you change that on in your workbook. Okay. And then let's look at an example for this. Let's see. Do you guys want b to be positive or negative? Okay, we'll do negative. So see example. What was that? Which example was that? Example or part C above. Above. Okay. So let's come up here. All right. And what I want to show you is this. If I was just graphing so consider y equals 2/5 times x. So we'll have, so in this case, do you see how it's different? If we're considering y equals mx plus b, all right, do you see that in this case, b would be 0. So if we plugged in those same points, how is it going to be different? See, remember how we came from here? When we plugged in 10, if we didn't have that plus 3, what would we have? We'd have the ordered pairs. We would have 10, comma 4, wouldn't we? And we would have, and let's examine where that is. 10, 4, 6, 5, 4. Do you see that's shifted a 3 down from the other one? So basically, if we wanted to kind of compare lines, what would happen is if you have the original y is 2/5 times x, and you wanted to graph, you knew the shape of that graph, and you wanted to graph y is 2/5 x plus 3, the y equals 2/5 x plus 3, each ordered pair would be 3 up. In the y part of it, the y shift would be 3 up from this one down here. So we'd have the ordered pair 10, 4. We would have 5, 2. Right? We would have 0, 0. And we would have -5. And we would be down to -2. And then we would have -10, and that would be at -4. Right? So do you see the parallel lines are the same slope, so they're going to be parallel lines, and there's just a difference in the shift, all right, up or down. Okay, so here we go. The application. So in 1960, per capita fish consumption was 10 pounds. This increased by approximately 15 hundredths of a pound per year from 1960 through 2005. These conditions can be described by the mathematical model F equals 15 hundredths times N plus 10, where F is per capita fish consumption in years after 1960. So if N is 0, what year would we be in? Good, we'd be in year 1960. So now instead of having an x comma y situation, we have an n comma f situation. So we'll let n take on these values 0, 10, 20, 30, and 40. And then we'll solve for f. So f in the first case would be 0.15 times 0 plus 10. So do you see that f would equal to 10? So we would have the ordered pair 0, 10. And then the f value that we got was 10. All right, so then if I plug in 10, f is 0.15 times 10 plus 10. Well, this would move the decimal 1 to the right. So we'd get 1.5 plus 10. So f would be 11.5. So we get the ordered pair 10, 11.5. And then here f is 0.15 times 20 plus 10. So this would give us 15 hundredths times 20 is going to be 3. So f will be 3 plus 10, which is 13. So 20, n equals 20. What year is that? Good, that's going to be 1980 because it's 20 years after 1960. Bothering me. Okay. And then moving along, 0.15 times 30 plus 10. So f will be, for this one, if you do the math on it, it will end up being 14.5. So we got 30, comma, 14.5. And last ordered pair, 0.15 times 40 plus 10. F will end up being 16. So we'll get 40, comma, 16. So this is, where we plugged in for n. And this is what we got out for, what we're solving for f. Okay. And then it said to graph the formula in a rectangular coordinate system. So we have to figure out what our axes should be, right? So we've got, these ordered pairs. The lowest x value is 0, and it goes all the way to 40, right? So I'm thinking that each of those, maybe we'll have each tick mark be worth 5. Okay, so this, and actually we're not dealing with x this time. Our horizontal axis is n, and our vertical axis is f. So here, if this is, 5, 10, 15, 20, 25, 30, 35, 40, 45, and then 50. Right? And then the y goes, the f axis goes from 10 to 16. So I think just like before, we might want to go by twos, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now we're not going to be, this model just starts at 1960, so we're not going to do any negative x values and negative n values, and we don't have any negative f values because f is per capita fish. We're not going to have a negative value, which means that we don't need to label the rest of the numbers. So here we go. We had an ordered pair at 0, 10. So that'd be 0, 10 right here. And then 10, 11.5. So 10 and then 11.5. So 11 would be right in the middle. So 11.5 will be like at the 3/4 mark of that tick mark. And then we have 20 and then 13. That'll be here. And then we have 30, 14.5. So that'll be about 1/4 of the way up on this one. And then we have 40, 16. All right, so here's our formula, assuming, it behaves in the same way forever. Okay, so now let's use our graph to estimate per capita fish consumption in 2020. So how many, what would I look for, right? 1960 plus, 60, I guess. So I didn't go quite far enough, but we can add on to our graph, right? So this would be 5560. That would be about up here. So I would guess from my graph, if we were to extend this line, we'd be at about 19 would be my guess for here using our graph. Okay, there's different ways. So approximately 19 pounds. Now let's use our formula, right? So we'd be plugging in N is 60, right? And then we have, F was equal to 0.15 times N plus 10. So F would be 0.15 times 60 plus 10. And this would give us, so 0.15 times 60. So 60 is like 10 times 6. So remember, times 10 was 1.5. So 6 of those I think would be 9. So we would get 9 plus 10. So F is 19. So we would say 19 pounds.